Okay, in lesson 10 of Mod 5, we went back to working with area models. So the difference is we're going to be working area models with fractional parts. And we're going to go back to how we learned area model initially in order to try to have a better understanding. And the first question, it was done for us. But I want to go through and show what they actually did. You see when they drew their model, what they actually did, they have 3 units across the top. So they split it up so that the 3 units across, each one was one whole. And going down the side, they split it up to 2 units, which this one here would actually be 1 also. This would be 1.5. So when they multiplied this out, this is 1 times 1. So the area of this one was 1. And the same with this one is 1. And the same with this one 1. When they multiply the second one's 1 times 1 again, they're still going to get 1 in each x cubicle. The last one, they got 1 times 1/2 would be 1/2. 1 times 1/2 would be a half here, and 1 times 1/2 would be a half here. When you add them up, you got 3 for the top, 3 for the next one, and we ended up with 3 halves, which would be 1 and 1/2. When you add those up, you end up with 7.5 units squared. On B, you can see now they're saying that it's 2 1/4 units long and 4 units wide. And as you can see what they did, they split it up once again with 1 and 1 for 2 1/4 units. Going vertically, they have 1, 2, 3, 4. So when they multiply these out again, they're going to get 1 times 1 is 1, 1 times 1 is 1, 1 times 1/4 is 1/4. And each one of these is going to end up the same. So when we add these up, and they added them up horizontally, so I'm going to go vertically. This one here would have been 2 1/4. This one would have got 2 1/4. This one would have got 2 1/4. And this one would have got 2 1/4. And we can see we add them up, we went 8 4/4, which would give us 9. So we have a total of 9 units squared. Now another way that you could have drawn this one, because we're wanting to get to that standard algorithm, I could have split this up where it was 2 1/4 and 4 units. Because I know this one here would be 4 times 2, which would give me 8 here. And here I've got 4 times 1/4, which gave me 4/4, which is equal to 1, and I would have a total of 9 units squared. So it just depends on which model makes sense to you. But we're wanting to get more and more toward the standard algorithm. On rectangle C, once again, we're going to start off by just drawing ourselves a rectangle. And this one says 4 units wide by 3/4 long. So I could come up and say that this is 4. And then I could split it into 4 if I'd like. And each one of these was 1. And this side was 3/4. And I know 1 times 3/4 would be 3/4. So each one of these is going to end up with being 3/4. And when I add them up, I got 3, 6, 9, 12 quarters. And 4 going to 12 3 times. Now the other model you could have done, if you didn't like to break it up, we could have went by 4 3/4, which is 3/4 times 4, which equals 12 over 4, which once again would have gave us 3 units squared. On D, It says 2 units long, 1 3/4 wide. I'm going to swap it around because it doesn't really matter how we change it up because we're multiplying. And this can be 1 3/4. Now I could split these up so that each one of these blocks are 1, and that makes 1 times 1 for this block, 1 times 1 for this block, 2 times 3/4, excuse me, I'm sorry, 1 times 3/4, which gives us 3/4 here, and 1 times 3/4, which gives us 3/4 here. So we end up with 2 6/4, which 6/4 actually equals 1 2/4. So we can see our answer would be 3 2/4. And some of you are going to say, yes, that can be changed to a half, and you are correct. It could also equal 3 1/2. Now let's look at the other standard algorithm model, because we know this would be 2, and I'm going to split this way, 1 3/4. So 2 times 1 times 2 for this one gives us 2. 3/4 times 2 gives us 6/4. So now we got 2 6/4, which equals 1 2/4, which we're back to 3 2/4 again. Now, what the standard algorithm looks like on this, okay, without the model. But if you don't use a model, you're going to make the typical mistake. And here's the typical mistake I see, okay, is we did this and we go 2 times 1 3/4 equals 2 3/4. And that would be a wrong answer, because all you're doing is 2 times 1 to get 2 3/4. What this actually means, 2 times 1 3/4, by the model you can see we actually did 2 times 1, and we had to add 2 times 3/4, which gave us 2 plus 6/4, which ended up giving us our 3 2/4. Okay, multiplying the 2 by the 1, you have to multiply it also by the 3/4. And that's the common mistake we see. The model, if you're doing the model should keep you from making that mistake. Okay, in question 2, Rachel had a mosaic from different colored rectangular tiles. 3 tiles measured 3.5 inches by 3 inches. 6 tiles measured 4 inches by 3 1/4 inches. What is the area? Okay, so we're going to start off by drawing ourselves a area model. So here's a rectangle, and hopefully by now you're seeing the area model with it. So I'm going to start off with the first one being 3.5 by 3. So this is 3, this is 1/2 times 3. So here we got 3 times 3 would be 9, and 3 times 1/2 would give me 3/2. So this one is going to equal 9 3/2, which equals 9 plus 1 1/2, which gives us 10.5 inches squared for the first one. Now, it says there's 3 tiles. So now we have 10.5 inches squared. So I'm going to go ahead and do 10.5, and we're multiplying this by 3 tiles, which is going to give us 3 times 10 for 30, and 3 times 1/2, which gives us 3/2. So now we got 30 3/2, which equals 30 plus 1 1/2, gives us a total of 31 1/2 inches squared for this one. Now the second one right here is 4 by 3.5. So I'm going to split this up by 3.5 by 4. So this is 3 times 4, give me 12. and 1/2 times 4, which equals 4 halves, which now gives us 12. 4 halves, actually that's 3 1/4, I'm sorry. So that's 1/4 times 4, which is going to give us 4/4, which is equal to 1. So this is equal to 13. Now the 13, it said that there were 6 of those. So we're going to multiply by 6, be 18, be 78 inches squared. So 78 inches squared plus 31.5 inches squared. It's going to give us 109.5 inches squared. Okay, a garden box has a perimeter of 27.5 feet. If the length is 9, what is the area of the garden box? Let's start off by just doing a model so we can see what we have. Now on this one it has 9 feet for the length. Since we know it's a rectangle, the opposite side has to be 9 feet. We know perimeter is 27.5, and a perimeter equals the sum of all 4 sides. And we have 2 unknown sides here. So we know the sum of these two is 18, and that's to equal 27.5. So if I take 27 and subtract 18 from it, I'm going to end up with 9 1/2. Now in order to split up 9 1/2 between 2 sides, I like to think of this way, because 4 plus 4 is 8, and I got 1 whole left over, so I can split them into halves. Now the half I can split into 2 quarters. So when I add the quarter to each side, I end up with 4 3/4. So I know these sides now are 4 3/4. Now we can go to what the question is asking, which is the area of this. And we know the length is 9 feet. And we know that the other dimension is 4 3/4. And I know 4 times 9 is 36 feet squared. And we got 3/4 times 9, which is 27/4. Now 4 going to 27 6 times. It's going to be 24 and 3/4 left over. That'd be feet squared. Now to find the total area, we have 36 feet squared and 6 3/4 feet squared, which is going to give us 42 3/4